So in this video, we are looking at quadratic models. Now, like all the other models we've talked about previously on this channel, a quadratic model once again describes a practical situation using the quadratic function in the form of y equals ax squared plus bx plus c. Now, quadratic functions, they are graphed to make a curve in the shape of a parabola. That's the one we were talking about before. So we're going to apply this to a couple of examples in this video. Now, example 1 says that the area of a rectangular garden of length x meters is given by a equals 6x minus x squared. It's saying first to draw the graph using the table of ordered pairs. So I have a table here. I want to sketch the graph by substituting into and filling out the table of values. So I'm going to go straight into it. You can pause the video and have a go at substituting on your own, but I'm just going to write in the values here. I have 0, then 5 when I sub the next one in, then 8, then 9, then 8, then 5, then 0. So now that I have these, I can go ahead and sketch this. So I'm going to write in my ordered pairs. So when x is 0, a is 0. When x is 1, the area is 5. When it's 2, the area is 8. When it's 3, the area is 9. And then it goes back down. So we have our graph here, and it lines up with these. We could already sort of tell that this graph was going to look like this, even just by the y values. It goes up to 9, then it goes back down. And notice the coefficient of x squared is negative. So we expect the graph to have a maximum turning point and look like this. So joining the dots, we want to draw a continuous curve that passes through each of these points. And we have our, our graph here. So, apologies. The next question is asking us to use the graph to estimate the area of the garden when the length of the garden is 4.5 meters. So we're going to locate 4.5. We're going to draw up until we hit about here. Okay, so this is just short of 7. It looks like it's around 6.5, maybe 6.6. So we're just going to estimate. So the length is going to be approximately, the area, is going to be approximately 6.6 meters squared. Now, we can also check this algebraically. So we can use the graph. Now, this question is saying specifically, use the graph. So we have to make reference to the fact we've used the graph. So showing this sort of dotted line. But we can also check it algebraically, okay? So what we can do, we have our rule, a equals 6x minus x squared. So we can sub in x equals 4.5. So substituting that in, this equals 6 times 4.5 minus 4.5 squared. And that gives us 6.75 meters squared. So we were in the ballpark, right? Remember, when we use the graph, there are some kind of human errors that can come up. It's really hard to get an exact value from a graph. So when you answer a question in an exam, there is a little bit of leeway that accounts for this, but we got roughly in the ballpark anyway. Now, part C is asking us, what is the maximum area of the garden? We can look at this by identifying the maximum turning point. So the x value of this is 3. So the length of 3 in the x produces a maximum area of 9. So the max area is given by our maximum turning point. So the area is the y coordinate of this point, which is going to be 9. So we can say max area is 9 meters squared. And last part, it's saying, what is the garden length in order to have the maximum area? So that is talking about the length. Now, the length is are the x values here. So the length that produces the maximum area is a length of 3 meters. So we can say that the maximum area occurs when x equals 3, when length is 3, or x equals 3. So we are applying this to a problem, and we're drawing our quadratic, and we're using this to identify the max area, and we can use the function to approximate other things. So we can find, for example, the length or the area when the length was 4.5. We could find the area when the length is 0.5. We can approximate anywhere along this graph as well. Now, this next video is it's not a sketching question, but we are trying to interpret the quadratic function. This is actually a past HSC question. So I'm going to actually write that here. Now, this tells us that an object is projected vertically into the air. Its height, h meters above the ground, after t seconds is given by the rule, h equals negative 5t squared plus 80t. Now, it's saying for how long is the object at a height of 300 meters or more above the ground. So first, we want to identify, because we've sketched this with time being on the x-axis, the height being on the y. So we want to find when is the height 300 meters and how long is it at 300 meters for. So I'm going to draw 300 meters along. I notice that this is when the object is first at 300 meters. That occurs at 6 seconds. And I can see everywhere from here until here is when it is at 300 or above. So this entire section is where we are looking for. This is what's going to answer our question. So this part is when it goes back to 300 meters. And we can see that that happens at 10 seconds. So from 6 to 10 seconds, this is above the ground. So the time above the ground, the time spent at 300 meters or above is 10 minus 6, which equals 4 seconds. So we have the answer A here. That brings us to the end of the video. This is how we can use our quadratic models, both interpreting one that's already been drawn, like in this example, or drawing our own quadratic function and answering the questions in the previous example. Thanks so much for watching, and I'll see you next time.